Hello everyone, my name is Daryl. I work as a software developer, and in this video I'll be continuing my Let's Play of TIS-100. Today we're going to be doing the interrupt handler level, which is level 9. Let's go ahead and get started on that. Okay, we got a lot of inputs and one output. So read from in1 through in4. Write the input number when the value goes from 0 to 1. Two interrupts will never change in the same input cycle. What are we doing here? Write the input number when the value goes from 0 to 1. Okay, so like in this first one, they're all zeros, so you're going to return a 0. Then it's all zeros, so you're going to return a 0. And then in this one, the fourth one became 1, so you output a 4. And then in this one, the third one became 1, so you're going to output 3, and then nothing changed. Aha, I see. And then when one becomes a 0, though, you still return a 0. It's just when something becomes a 1. And it does say that two interrupts will never change in the same input cycle, so it's always going to be 1 that you're detecting going to 1, and you don't care if it switches to 0. Okay. It was nice that we're only going to have one interrupt at a time, so this shouldn't be too bad. Let's move up to ACC. If it's equal to 0, we want to go to EZ. But if it's not equal to 0, then we want to swap ACC and back. And then previous value. So basically, we're always going to try to be storing the previous value in BAK. And so if it was 1, because it wasn't equal to 0, then we swap. And if now it's 0, so JEZ to int, but if we swapped it and it was still a 1, then we did just JMP to end. Now we want to go ahead and fill these out. So EZ, if it's equal to 0, well, if what we got is equal to 0, then we just want to save. We just want to save that. We don't need to care about it. We just save it into back, and then JP and int. So that means like we're doing the interrupt. So if this one was the one that was interrupted, then we want to move 1 to down and have end here. So what I kind of want to do is I'm going to try to do the exact same thing as this, copy it all over to these, and then just have it, if it ever gets interrupted, to pass it down. Now, obviously, the one thing that I'm worrying about with this solution, and we'll have to just give it a shot, is do you need some sort of mechanism to where you're keeping these all in sync so that they're all looking at the same row at the same time? Like if I just do this and all 4 of these, are they going to get out of sync and then cause a bunch of issues? That's a possibility. Now the one thing, so we need to make sure that if, okay, now I see how this is going to work then. Because we need to pass a 0 if there wasn't an interrupt. Okay, I see what we're going to do here. Okay, so if we, let's see, so in the case of, if it's equal to 0, we're going to swap. And then if it's equal to 0, then we go to the interrupt. Otherwise, equals 0. If we either get a 0 now, or if we swap. I think what'll work, so change end to ZR. And then put end here. I think that will work, just having this be move 0 down. So we're going to have to pass on a 0 or a 1. You know, this will be a 0 or a 2. So we should be able to basically copy this. It's going to be the exact same thing, but this is going to pass down a 2. This would pass down a 3, and this would pass down a 4. Now with the piping here, so now that we have these labeled 1, 2, 3, or 4, we don't need to care in what order they actually make it to. This is where I'm going to do some calculations. So we just need to do move. I guess we can try, let's just do this. Move up, right, and then we'll start this one by accepting that one. So move left, right, then it's going to move up, right. And this one is going to move left, down, move left, down, and move up, down. This one's going to move up, left, and then after doing that, this is going to move right, down. So technically these should end up getting their in order, I believe, but that doesn't really matter. So we're going to move up into ACC. If it's equal to 0, then we're going to want to do something separate. Let's just go ahead and put that in here. If it's equal to 0, and we'll put some code above. But if it's equal to 0, then we want to SWP add 1 SWP. Well, actually, after add 1, save. I might need to split this up into another node. We'll see. Sub 3, if it's greater than 0, then go to RO, and RO would move 0 down. Okay, I'm probably going to need to do this in a couple different nodes. Okay. All right. Just because there's going to be too much. So we still need to have this easy, but we need to offload some of this processing since it's going to take too many lines. Equal to 0, then we're going to move 0 to left. And then we'll have end here. So here's where it's not equal to 0. So if it's not equal to 0, then we want to move ACC down. Then we want to move -1 left. Now here, we want to do the other processing. If we have to move 0 to the left, then we need to move left into ACC because the left one's going to do some processing and return something, only in the case where we got a 0 here. And if it's less than 0, then we're going to go to RO. Well, how about we do, yeah, go to RO. If it was otherwise, we want to move 0 down and JMP end. RO. Actually, rather than having a separate thing, just do end if it's less than 0. Yeah. So what this is going to do, this is going to move right into ACC. If it's less than 0, then go to LZ. If it's not less than 0, then we're going to swap add 1 save or SWP JP end. And then we're going to have LZ here. So if it was less than 0, then that means that we got a numerical value that we passed and we need to reset. So we're going to say move 0 in ACC, and we're going to save that to back, and then we're just at end. But if, okay, so one thing here, you're going to add 1, do a save, and then you're going to do sub 3, and if it's still greater than 0, then we're going to want to, well, if it's, let's sub 4, and if it's less than 0, then go to end. If it is equal to 0, then we need to move 0 right. But if so we also need to do this. We need to do RNO, which is going to be JP end, and right here we're going to have RNO move -1 right. So I doubt this is going to work on first try. Let's see what breaks. Okay. Oh, okay. One more thing I think needs to happen here. Yeah, so when we move, all right, we're going to need to make a little bit more space here. Because when we move, after we move -1 to the right, we just want to save? No, it's not when it's a -1. After we pass a 0, we move 0 to ACC, and then we save. After you move 0 to the right, it's safe to just say save at that point. Does that help? Okay, now it appears to be working thus far. Oh, I spoke too soon. Got farther. Got the first 7 correct. And this one should have returned a 3. We want to JMP end, I believe. Whoop. Now we got it stuck. All right, let me watch that again. That's the problem. After it moves -1 to the left, we wanted to JMP end at that point. Okay, it's messing up again. Instead of having this jump to the end, I'm thinking save the value when this is the case into BAK. Then go ahead and move a value to the left. At 0 is fine, actually. Maybe we actually want to get rid of this then. Don't move -1 to the left. Just save, move 0 to the left, and then when we get here, we're going to take the value back. And here we'd want to move the 0 down, but we just want to say SWP JLZ end, or actually GG JGZ end. SZ, if it's less than 0, go to end, or if it's equal to 0. Otherwise, move 0 to ACC and save. JMP end. Oh, but actually, instead of jump end, this doesn't need to have jump end. We can do jump RO. RO will be that. Dang. It's failing differently this time. Alright, so I think I might have figured out what the problem is, and it's actually in here. In all of these cases, after you move that down, it's moving a 0 down as well. We need to do JMP end here for all 3 of these. Or all 4 of these. Let's try that out. Looks like it's working a lot better. I'm gonna go ahead and say fast. All right. So, so apparently the solution's very bad when it comes to cycle counts. Apparently there's a much better way to do that. That's very interesting. Then we have node count. I mean, node that's, you know, about average and a lot of instructions. So apparently that's a pretty bad way to do that. I mean, it works, but apparently there's a lot more efficient ways to do that. I may need to look up at some point what those are. All right, so that one took a little bit longer. I think I'll probably have cut out a lot of the debugging that I did. I think I spent over an hour debugging a bunch of different stuff with the way I was doing that. But anyways, that's going to be it for this episode. Next time, we're not going to do a simple sandbox. We're going to be moving over to signal pattern detector. So, all right, hope that helped you guys out, even though that wasn't particularly good of a solution, apparently. But thanks for watching. I'll catch you guys next time.